All right, today we're going to dive into something called Oracle SQL constraints. Now I know that might sound a little dry, a little technical, but stick with me. Because these are basically the unsung heroes of your database, quietly working in the background to protect your data and make sure everything just works. So just think about it for a second. With all the data flying around, what's the actual line of defense? What is really stopping messy, incomplete, or just flat-out wrong information from getting into your system and causing total chaos? Well, that's where constraints come in. They are those unsung heroes, the automated guards on duty 24/7, keeping everything consistent and in order. You know, without them, even the most brilliantly designed database can turn into a mess, and fast. The best way to think about constraints, they're like the bouncers at a really exclusive club. And that club is your database. They've got a strict guest list, a set of rules, and if the data trying to get in doesn't meet the criteria, nope, you're not on the list. It's not getting in. It's as simple as that. They're the rules that stop bad data before it even has a chance to become a problem. Okay, so first up, let's get into the rules that are all about identity. How does a database know for sure that this record is different from that one? Well, it all comes down to giving each piece of data a unique fingerprint. So here they are, the big three when it comes to identity: primary key, unique, and not null. Just take a quick look at how they differ, especially when it comes to allowing duplicates or those empty null values. Let's break each one down. The primary key. This is the big one. It's like your national ID number. Everyone's got one, and no two are ever the same. It's the ultimate identifier for any record in your table. It has to be unique, and it absolutely cannot be empty, period. Next, we have the unique constraint, and a perfect real-world example is your email address. In any given system, your email has to be unique, right? Two people can't have the same one. But have you ever signed up for something where providing an email was optional at first? That's the key difference. This constraint says no duplicates, but it will allow for one single entry to be null or empty. And then there's not null. This one's the most straightforward of the bunch. Just think of it like your name on a form. It has to be filled out. Now, it doesn't have to be unique. Of course, there are plenty of people with the same name, but that field just cannot be left blank. It makes that piece of information mandatory. Okay, so to help make all that stick, here are a few simple shortcuts. A primary key, or PK, is just a unique and a not null rule combined. The unique constraint is unique, but it allows for one null. And not null? Well, that just means it's mandatory. Simple. All right, so we've covered identity, but that's not all constraints do. They also play a huge role in managing how different tables connect and talk to each other, and in validating the actual data that you're trying to put in. This is a big one, the foreign key. A foreign key is all about building valid, logical relationships between your data. It's basically a column in one table, we'll call it the child table, that points directly to the primary key in another table, the parent table. That little link is what keeps all your data connected and consistent. Here's a great way to think about it. You can't get a student ID card for a school that doesn't exist, right? You have to be enrolled in a real, registered school first. In this case, the student record is the child, the school record is the parent, and the foreign key is the rule that makes sure that link is always valid. And why does this matter so much? Well, get a load of this number. Foreign keys are responsible for preventing a whopping 90% of what we call orphan records. That's data that's just floating around, disconnected, because its parent record is gone. And let me tell you, that is a massive source of bugs in big applications. Okay, our next tool in the box is the check constraint. This one is your custom rule enforcer. It lets you define a very specific condition that the data in a column has to meet. So you could say a salary must be a positive number, or that a discount percentage has to be between 0 and 100. So, for instance, a school might have a business rule: students have to be older than 5 years old to enroll. A check constraint takes that exact rule and bakes it right into the database. It will automatically reject any new student record if the age doesn't meet that condition. It's a business rule turned into a data rule. So, to boil it down again, a foreign key, or FK, ensures you have a valid relationship. And a check constraint ensures you have a valid value, or a valid range of values. Now, we're going to get into something a little more advanced, but it's absolutely critical to understand. Once you've set up these relationships with foreign keys, what happens to the child records if you delete the parent? This is a huge decision you have to make when you're designing a database. Your two main options here are restrict and cascade. Restrict is the default, and it's definitely the safer choice. It says, nope, you can't delete this parent record because it still has children that rely on it. Cascade, on the other hand, is the really powerful option. It says, sure, go ahead and delete the parent, and I will automatically find and delete all of its children too. I love this analogy. Using Cascade is like ripping an entire page out of a photo album. You don't just lose the page itself, you instantly and permanently lose every single photo that was stuck to it. It can be incredibly useful, but man, you have to be absolutely certain that's the behavior you want before you set it up. Okay, so let's zoom out and bring this all home. Why did we just spend all this time talking about these database roles? Because constraints are not just some nice-to-have feature. They are the absolute foundation of any reliable, trustworthy application. This right here, this is the whole point. When things go wrong in a live system, when users start seeing weird errors or the data just looks wrong, so often you can trace the problem right back to this, a constraint that was missing or one that was poorly designed. They are your first and your best line of defense against bad data bugs. In the end, it really just boils down to this simple equation. If you want to build systems that are tough, that are predictable, that people can trust, you have to master constraints. Truly understanding how to use them is the key to making sure your data stays clean and reliable for the long haul. And so I'll just leave you with this one final question to think about. When you look at the systems you work on every day, are the rules in place? Is your data's bouncer doing a good job, or are you maybe letting a little bit of bad data slip through the cracks? The answer to that question can make all the difference.